So we're back at Swiftune for a third day, and today's a very exciting day because it's engine day, and I'm here with the engine master, Nick Swift. These motors, these mini motors, they're your bread and butter, aren't they? You've been doing them for absolutely years. When did this all begin, Swiftune making engines for minis?
So yes, absolutely years. My old man started the company back in 1965. Then it basically was a very grassroots, small thing. They'd come out of the motorcycle racing world because he was fed up with breaking limbs and bits, and said, "Oh, fancy a mini." It already had a mini on the road, I think it was. So, and in the 60s, lots of autocrossing and stuff like that. So he started building his own engines, then started winning, and then people said, "Oh, can you build me one of them?" And you know, that normal story. And basically, through the ages, you know, we have progressed to being, you know, quite renowned in the mini world, purely because of the engines, which there is no real major trickery. It's just a case of making them obviously as fast as you can, which, you know, anybody can do that, but it's making them reliable. You've got to keep them strong, as you know. A lot of the historic racing, the master stuff, MRL, whatever, they're 1 hour races. So you get the old heavy-footed drivers.
I don't know of any.
No, there is none. In the historic world, they're all gentle.
Gentle.
But you've got to make it last, you know. So reliability is the massive key, and that all comes down to component selection. Our R&D programs continuously running all the time, trying to improve whatever it is: crankshaft, counterbalance, mass, blah blah blah, comrods, pistons, everything to make it as strong as we possibly can. And then your normal development of cylinder head, camshafts, carburation, to get as much power as we can. So essentially, obviously to conform with all the 1965 regulations that we have to follow, so we've got to use this, basically the stock block and cylinder head, but we're lucky enough in the terms of we went through a lot of pain, so lucky enough, we developed and reproduced the cylinder head, and we have FIA approval to do that. But essentially what you see there, the block, again, the FIA allowed us, because there would have been original Cooper S blocks up until about, I can't remember what it was, 15 or 20 years ago, I think it was. They allowed us to use a slightly later Austin 1300 GT block, but that we still find them as standard core units. So there is development at this moment in time going forward to producing a new block, which just makes life much easier, because you know, you're dealing with something that's already 50 years old plus. You don't know what its history is, and actually trying to find them. Every one you use is another one gone. No one's replacing them. So it is getting quite hard. The cases, the gearbox case, you know, the covers, rocker covers, they're sort of original parts. Everything else, predominantly inside, is changed.
Coming up 60 years of Swiftune engines, and I have one in build. I'm very excited to see the motor that's going to go in the Incredible Hulk over here. So can we...
About the car or me?
Let's go and take a look at a motor, shall we? Transition. So, it's an engine block.
Correct, well done.
Thank you. I'm an expert.
Yes, it's getting there now. So this one, actually, the customer that we're building this engine for, he's actually asked for a Cooper S block, the original, as we said, talking just now, about the BMC A-series block or the Cooper S one. This one is a Cooper S. So what we do is we have to then remanufacture it, as it were. We put new liners in the bores, we can get the correct bore size, etc. That we're looking for, and the overall height. BMC manufacture it, fortunately, with slightly bit more, give us a bit more leeway to machine it to where we want to get the perfect compression ratio versus squish, etc.
So in some ways you're putting kind of a block in a block with the way that you've relined all the cylinders and then just tweak the height.
Yes. So this big cast iron bit just facilitates what we want to do.
Yeah.
So that gives it, so we would reline bore the main caps, etc., etc. So everything turns beautifully, a lot less friction. Everything's obviously about attention to detail, the very smallest as we can.
So you've prepared the block, sorted that all out, then what goes next? Presumably you start building components and putting those in.
Yes, exactly. So the crankshaft in this one is already in. This is a EM40B steel replacement crankshaft that we have then machined to give us what we feel is the optimum counterbalance. Literally, Cooper stroke, we have to conform to the regulations of stroke, bore size, etc., etc. It's all homologated. They are at 1293 cc, which is the standard plus 20 oversized from the standard bore. And then we then, so this would be our rod and piston package. You could see nice, lightweight, strong. It's got to turn, so we've got to get that as stress-free as we can at 8,000
So you're
RPM.
revving.
Yeah, so
I was about to say rev to 9, but I'm probably not supposed to.
it's that sort of calm, gentle, historic racing, Alex,
For those who I recognise a lot of our followers are going to be very car-y. For those who are not as car-y, bore, width of the cylinder, stroke, distance of the movement of the piston.
Yeah, the throw, as you would describe it. So
apologies to those who are very car-y for wasting moments of your time.
So the only other thing that slides into the block will be the camshaft. So this is where we spend a lot of time in R&D, is to get the camshaft enables, obviously this is going to open the valves. So camshaft slotted into the block, and because it's old design, obviously it's push rod, which is going to come up there. We'll show you that in a sec. And then the cam design, which quite simply all it's doing is increasing the amount of lift that it opens the valve and how long it's open for.
Yep.
So you get opening and shutting time, so you can just see from the shape. But as it's revolving, it will then lift the cam follower, which pushes the push rod up, etc. And it's that period here, and that's literally as it's described, you would say the period that it's open for. So
the design, so the magic in these, it's all about rotations without friction, isn't it? And the finish of it, and
yes.
and the ability for it to turn without generating friction in the rest of the engine.
So once we get that developed design that we're looking for, then you can see, it's very, very shiny, because that ultimately is a friction-based thing. Anything that rubs together, if you can take away anything of that friction, it will release more power. So
I feel like that's going to be a running theme all the way through the build of everything. High rev, low capacity motor, yeah?
Yeah, exactly. You get, little old 1950s design that originally, don't forget, this came out of the factory to suit Mrs. Miggins in the little, the brand new Mini in 1959, and it had a wholesome 25 horsepower, So now, all of a sudden, we're sticking at least another 100 horsepower on top and doubling the RPM. So that's where it comes back to that. You can create that power. Now we've got to harness it, we've got to hold it all together and make sure it can withstand your big old foot on the throttle.
What's next? I'm seeing a set of cylinder heads. So talk me through these.
Okay, so the top end of the engine, the cylinder head, as I said, FIA approved, so the governing body of historic motorsport in general, but the historic section gave us approval to use this cylinder head. Yeah, we have to go through that whole rigmarole.
So this is one you produce,
yes,
but to the spec.
Correct.
The FIA
they are happy
require.
With, literally you go through that process. You have to send them all the drawings, and then you physically send them the manufactured cylinder head. they fire it back to you 2 or 3 times and go, change that, can't have that, you know, do that. And then once it's gone through all that rigmarole, they then say, yep, that's perfect. And what we get is a sealed version that we then always have, which is the one they originally checked. So what I'll do is, again, in the development of airflow, because we've got the camshaft obviously allowing the valve, the amount and the length of the valve lift. So we need to match that with the amount of airflow coming through. So we've got a lot of development goes into the cylinder head. And again, the material taken off the head gasket face and gives us the size of the chamber allows for the correct compression ratio. And then once you've got, also as part of the cam, it's your rocker ratio. So because we're a push rod, good old fashioned push rods,
Yeah.
Literally as that cam lifts up, opens the valve,
Yeah.
obviously shuts again.
Valves on the springs.
Valves on the springs. The springs shut the valve again, but obviously the springs can determine your RPM. So ideally you want to keep as least poundage on them, but you've got to have enough poundage to be able to get to RPM. Otherwise you get valve float.
Bit of bounce, yeah.
And even when you're, driver in any vehicle, whatever it is, you could have
That's
that.
how you know how to change gear, isn't it? When the valves start
Oh,
bouncing.
yeah, that's perfect. That's an engine builder's dream. Oh, have you ever revved it, sir?
Don't know what you mean. Revs to 10, doesn't it? No. So you're balancing this, and then of course your carbs go on top.
Yes.
And control the airflow in and the management of the throttle.
We are a brand new SU carburetor, remanufactured by Berlin. They are SU, the SU people, Mark Burnett and his gang, and you can see we can develop this trumpet bit. So we developed our own shaped trumpet, the angle, the size, etc., etc. But that bit, the hole here has to be 1.5 inches size.
And that's your limit.
That's the
your
limit.
inlet.
That's homologated. So we can't change that. So now that's why we've got the particular camshaft, the particular cylinder head pattern, particular rockers, all to go with these carburetors.
Ever critical, of course, because the placement of the actual intake is quite far back, isn't it, in the engine bay and sort of over the back of the motor. So you must have to work around that a little bit.
Yes. So you've obviously restricted, because literally you've got the bulkhead of the car is here.
Yeah.
Like the bottom of that trumpet will touch the bulkhead.
Kind of need a big scoop.
Yeah. If only we were allowed. You know. So there's no air scoop. There's no cold air feed. Blah 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 blah. Obviously, it's controlled in a very rudimentary fashion. You know, it has a needle, so literally the dashpot is raised up by the air being sucked through. We'll show you that when we're on the dyno. And it's the thickness of the needle that allows through the main jet, so the fuel comes in here, and it's sucked through here, up, in, comes out into the engine there. So we've got to get as much airflow as we can with that. And then we've got to be able to get the fuel mixture to give us safe without it melting pistons, etc., etc. So yeah, so the trickery, if you like, or the attention to detail ever most important is the compatibility of cam, head, carburation.
A lot of balancing. A lot of balancing. I can feel the hours of work that you've put into it in the way that you
look at me. I'm 23 years old.
in the way that you describe it. This, I'm told, is actually the motor that will eventually go in the Incredible Hulk.
Yes.
And so I'm very excited to stand here with it in bits. Mini engines, of course, not unique, but interesting because it comes as one piece with the gearbox, which is another factor in the production of the engine. Should we go and have a look at one?
Let's have a look at the gearbox. There's one going together now.
Sits on the base of the engine and delivers power, and it's all one little tidy little unit.
Yes, as part of that whole original 1959 Isogonous design, which was to be able to get it as compact as possible. Normally, obviously, you'd have rear-wheel drive and the whole gearbox and axle and everything coming through. What's that funny thing? Prop shaft coming through to the axle. But the design is the sump, essentially, is the gearbox. You know, so that was the clever trickery way of doing it. Downside is, obviously, we've got gears that are all getting mashed about in there, and this is your oil pickup pipe that is feeding the oil to the engine.
So where does that sit then, in the
That
base
sort
of the
yes,
base
it
of the
sort
box?
winkles its way into there and connects. It sucks up from the bottom of the sump up through that pipe. That comes into the engine, sucked up through the oil pump. Blah 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 blah. So what you have is all that debris in the bottom. That's where, you know, smooth gear changes are the key to sort of reliability.
And then, of course, a dog box now.
Yes.
Were they a dog box back
No.
in the day? They were a
No.
they were a synchromesh
They're
box.
a synchromesh box, would have been a 3 synchro, so there is a, you know, bit of a story there in that with, you know, not really supposed to have that in there, but it's a case of the 3 synchro design is so weak that you can't, I mean...
Literally not just,
Yes.
It's a case of you can keep them period correct, but there'll be only very short races because that's as long as they'll last
That's the
for.
problem, you know, and you won't have the mass of minis out on the grid because you just can't keep the reliability. And, you know, we've had many stories of, like, many moons ago, you know, travelling off to deepest southern Europe or something to, you know, wherever it is, Monza or whatever, and drive all the way from here with the Mini on the trailer, do 3 laps in qualifying, bang, put it back on the trailer, drive home again, you know. So these, ultimately, it's not going to give you that much of an improvement in performance,
Just
but
make sure it works.
gives you reliability. So these are nice and strong. As you can see, we go through the super finish process again. Anything that the same as the cam, the same as the other butts, anything that mates against each other, running surface, it spins much freer. So you can see we run a modular lay system. So if this 3rd gear, for example, if that wears, we can literally just slip off these 2 gears, replace that one, rather than having to replace the whole assembly. Yeah. So that's what sets us apart from some of the others. You know, all the rest of it, see, once you've created, you know, what you've got, your drive, as it were, coming off the end of the crankshaft, you've got to get it down into the gears. Normally, you would have the end of the main shaft going into your flywheel as clutch assembly. You know, that's over here, and our drive is over there. So it has to then run on the drop gears. So essentially that then comes through down these gears. There's another primary gear here. Here we are. So there's a primary gear there. So them 3 gears mate, yes?
Yep.
That runs down, transfers the power into the gears, out on the diff, out to the drive shafts.
It's all it's a very claustrophobic little system, isn't it?
Compact.
Very compact.
That is very compact.
So once you've finished plonking all that on the bottom of the engine, or you've finished building the engine at least, you've got to go and test everything.
Yes.
And you've spent hours and hours on your dyno, which is
Yep.
just out here to the right.
Yep.
You give us a feel for what you do over there?
Perfect. Let's go and have a look.
So, mini dyno.
Yes.
It's a mini dyno, and
Well, it's a dyno. It's an engine dyno. So this is a Superflow American firm. It's like, you know, the largest supplier of, you know, dynos in the UK, in the world, I would say. A nice compact dyno system. We've adapted it to be able to fit the Mini engine on. It actually runs a Ford bell housing here.
Okay.
The way that we've done it, we bolted a Ford bell housing to there. You can see by the shape of the dyno, it's sort of made for V8s,
yeah,
i.e. American stuff. So because they would have the exhaust manifolds coming down and going through this.
Oh, through
big
the
here.
gap where it's,
So
yeah.
there's the same on this side, so they would have come out like that.
Yep.
So obviously, again, the Mini side of it does bring its problems.
Yeah. Sorry, I'm just looking. I'm looking. Yeah, okay, out there, fine. Yeah.
The exhaust.
Yeah.
It goes that
Yeah.
way. So the bolting, getting that power transfer, obviously off the end of the crank. We don't want to turn the gearbox.
Yeah.
So we have a different flywheel arrangement that then just has a drive that comes straight out, and it's a water brake, so it's all controlled by water. The more water, the more load, etc., etc.
So you're zooming away, you're whizzing your water about, you're pumping your exhaust gases into the lounge of the people next door, and so what you actually what are you looking for?
A gas mask over there.
Yeah.
So ultimately, so the first stage, so a brand new engine comes straight out the engine room. Wheels in here. This whole trolley wheels, we wheel it out.
Oh, okay. So you wheel it out
comes
like this and
we
plonk it
bolt
on
it
there.
on there, and then we wheel it in, and bolt it on. It then needs to go for a running in process.
Okay.
So we need to get the piston rings nicely bedded into the bores.
Yeah.
That running in process. That then, you do that correctly, then that gives you the longevity of nice seal in the bores. The better the seal in the bores, then the more power you're going to get, because it's not wasting it and blowing it all down into the sump. Then you would see, that's when you end up with, and you're scratching your head on the side of the track going, shit, all the oil's everywhere, it's come out the catch tank, it's all over the place.
Yeah.
Essentially, it's lost its seal. It's probably
you
melted
just get
the piston or whatever.
blows by
it
the
just
piston
blows
rings.
by, and it's
Yeah.
there.
The
So,
piston rings sit around the edge of the piston and seal up the combustion chamber, so you don't get fuel and air in oil system or oil in fuel and air system and all the bits in the wrong places.
yeah, exactly. So the running in period is very, very important. So we go through different loads, different revs, etc., through probably like an hour-long process to get where we're happy of what we want. And then once that's started, once that's completed, then we can then go through. So on the distributor, that's going to give us our advance retard. Again, historic rules, we have to use the mechanical advance bob weight springs inside the distributor, and then obviously then in the carburetors themselves, the needles that we talk about. Sorry.
So then you're picking lean rich on your carbs and deciding how much fuel you're going to be putting in.
This is our lambda systems.
Yep.
So that will measure lambda, and we're looking for flat out, wide open throttle, load running. We're looking for sort of 0.88, 0.89 lambda. That's nice and safe. 0.9, anything above that, 0.92, you're running precariously weak.
So you're obviously running these here. Lambda will change, of course, with different ambient conditions when you go in somewhere closer to sea level, where the air's a bit thicker, or you're going somewhere with a little bit of altitude.
Yes.
Can you give the customer then a feel for how they should change things for those?
That's where it does become difficult, because obviously then just changing needles, if I said to you, okay then Alex, you just need to change your needles, it's going to end in a disaster, to be fair.
Yeah.
So
everything I do does.
Not everything. So
you've seen the colour of my Mini.
I love that colour.
Yeah. Got a feel for what you're doing here. The question is, can we hear some revs from this one? It looks relatively ready to go to me.
It is ready to go. So we've gone through our running in process. We've already sort of put in a good base setting point. So we're ready to fire up and go.
Let's give it some action.
we see over 130 horsepower, perfect. Yeah, so that's good, you know. And you essentially you're looking at 100 horsepower per litre, you know, or over.
Yeah.
So on this wobbly old 1950s 3-main bearing design pushrod engine on a pair of little SU carburetors, 100 horsepower per litre. It's not bad.
When you think you've got 5-litre engines delivering like what 400 at the wheels.
Yeah, exactly.
Yeah,
I mean, I don't know what the Stang produces.
That about 430 on the dyno, about 400 at the wheels.
Right, and that what's that? 7 litres.
5. Is when we're finished with it. No, yeah, 4.7, aren't they? They're 289.
Yeah. So is that what it is? Yeah, 4.7. So that's what it's sort of giving, isn't it?
Yeah.
You know, so pro rata, 100 horsepower per litre.
Yeah, definitely. Our engine in build will be going into the car very shortly. The next time you see this car, it'll be ready to go on track, and we will be at a track. I'm not going to tell you which track, mainly because I don't know, but we will be at a track to shake it down, which will be an exciting day. We'll have the driver who will be debuting this car with us on track as well. So very exciting, and can't wait to get the rest of the machine together.